Hello class, and welcome to lesson 5.1, common factoring. Before we get to common factoring, which we did start or touch base on in grade 9, we're going to just do some warm-ups here on expanding. Okay, so to find the product means to expand or to multiply. So for the first one we use distributive law, and you should end up with negative 6d cubed plus 12d squared minus 9d. Okay. All right, taking a look at B, folks, it is a distributive law, but I actually work backwards, so I kind of do it this way, okay, because I use the monomial first. So I would take a look at it being negative 12 e to the fourth plus 6e cubed plus 21e. All right, C is an example that we learned in multiplying binomials is FOIL, first, outside, inside, last. Hopefully by now, folks, you've got the pattern down. You don't need the brackets or the arrows, but if you need the arrows, by all means, put them in. Okay, so we're going to go 6 f squared g minus 15f on the outside. Inside is negative 4 fg cubed and plus 10g squared. Notice, ladies and gentlemen, there's no like terms here, so you can just leave that as is. All right, now we're getting into some harder stuff. We're doing some foiling and some expanding. And because, folks, I'm going to need some more room, apologize, give me a second. I'm going to make this a bit easier for me to have some more room. Hopefully that's enough. Okay, so ladies and gentlemen, we've got to do 2 foils and a distributive law here. And actually, in 2 distributive laws. Oh, we're going to be busy. So foil this one out, so it's going to be x squared plus 7x minus 3x minus 21. Okay, now do your distributive law in the second bracket to remove. Negative 10x plus 2x squared. And now for the last one, folks, this is a distributive law and a FOIL. So we're going to do the FOIL first. So I need a bracket because the negative sign affects everything in the bracket. So first is going to be 12x. Outside is negative 6x squared. Inside is negative 24. And last is plus 12x. All right. Okay. So ladies and gentlemen, you can again collect like terms, or if you look at my answer key, I've left all these terms and I collect like terms at the end. But there's nothing wrong with going x squared plus 2x squared is 3x squared. Collecting your x's, 4x minus 6x. And negative 21, and then collect like terms in here. It's going to be negative 6x squared. Collect your x's, which is going to be plus 24x minus 24. Okay, do your distributive law, so you leave all the other terms at the front the same. Again, you can collect those or not collect them. It's okay. Now remember, when you have a negative out front, changes the sign of everything inside. Okay, so change your signs on all the terms, and now collect like terms. So you should have 9x squared minus 30x and plus 3. All right. Awesome. Now the last one applies to last day's lesson where we square it. Okay. So what I'm going to do is I'm going to do the short form, which we learned yesterday. So square the first, so c times c is c squared. Double the product, so 2 times c times 3. It's going to be plus 6c. Square the last is plus 9. Minus 4, do the same thing here. Square the first, so 5 times 5 is 25. Double the product, so 2 times 5 times negative c. Okay, it's going to be minus 10c, okay? And then square the last, so negative c times negative c is positive c squared, okay? Once you've done that, ladies and gentlemen, we can do distributive law, so it's going to be 2c squared plus 12c plus 18 minus 100. Watch the negative sign here. Negative times negative becomes a positive 40c and minus 4c squared. Now collect like terms, ladies and gentlemen. You're going to have negative 2c squared plus 52c minus 82. All right, on to today's lesson, common factoring. We're going to learn from the next 3 or 4 lessons, we're going to learn all different methods of factoring. The common factoring is the only one that we exposed you to in grade 9, but we're going to add on to it and make it a little harder, okay? So first of all, we're going to take a look at common factoring. Okay, factoring is the opposite of expanding. I know I'm jumping ahead of the game here, but that's important to remember. So when we were expanding, we were multiplying. So the opposite of expanding means to divide. So that's what we're going to be doing. We're going to be doing dividing. Okay, and I'll show you what's going to happen. Okay, we're going to start with a question like this, and we're going to end up like that. So we're working backwards. Okay, so we're going to start with a question like that. We're going to end up with something like that. But before we get to actually showing those factored forms, ladies and gentlemen, we're going to write all the factors out of 12. Just remember, maybe put this at the top. When we're common factoring, we're focusing on dividing. Okay, so we're going to, sorry if I could spell that, dividing. So we're going to divide when we factor. Okay, so what are all the factors of 12? Okay, so 1 goes in evenly into 12, 2, 3, 4, 6, and 12. Okay, all right. 20, here's another way to do it. 1 times 20 gives you 20. 2 times 10, so I go opposites, right? 4 times 5. Okay, so that gives you all the factors we have. So 1, 2, 4, 5, 10, and 20. Okay, try the next two on your own. Let's try and see if you can do this. So 1 and 18, 2 and 9, and 3 and 6. Okay, 54 is a bit bigger, so I'm going to start up here. I'm going to go 1 and 54. Okay, and then I'm going to go 2 and 27. And then I'm going to go 3 and 18. Okay, and then I'm going to go 6 and 9. Okay, so it's a bigger one. Cool. Why do we need to know those, folks? Because we need to know what number divides evenly into a solid number. If you have trouble, ladies and gentlemen, with your mental math in terms of don't remember your division or your multiplication table, by all means, see Miss R in class and get a matrix, which is a times table, and you may use it on your tests. Again, I'm not here to test your mental math abilities. I'm here to say, hey, if you need this tool to help you to be successful, by all means, go ahead and do it. Awesome. Okay. Remember, folks, when we factor, we express it as a product of 2 or more factors. Okay? So to factor a polynomial means to express it as a product. Okay? And to express it as a product, therefore, you need to divide to get it into 2 terms. Okay? So we know that if we expand, which is going this way, you take use distributive law and you expand this way. The opposite of expanding is factoring. So make sure you write this down, folks. When we go to factor a polynomial, we must think of the number and the variable that can be divided into each term. And we should have remembered these short forms from last year, GCF. And if you're not sure what that means, that's the greatest common factor. I'll write it in here. Okay, so what's the biggest factor that goes in here? So let's take a look at some examples, folks. I'm sure you'll find you remember this as we go. So for this example, what can be factored out of 3x and 12? Well, we know 1 goes in, but we want to look for the greatest number. So what number goes into both 3 and 12? And hopefully you understand that it's 3. So that's going to be my greatest common factor. It goes out front, and then your leftovers go in the brackets. How do you figure that out? You take each term. So for example, 3x, we're going to divide it by 3 to get by this greatest common factor. Our 3's cancel out, so our first term in our bracket in terms of leftover is going to be x. Then we take a look at our second term. Positive 12 divided by 3. Again, 3 goes into 12 how many times? 4 times. So that's going to be plus 4. So just remember, folks, that what's out front is your greatest common factor. What's inside are what we call the leftovers. Okay? Okay, so what we've done, folks, is we've just factored our first expression. Okay, notice now it's a product of 2 or more things. We've got a term called, a monomial called a 3, and a binomial called x plus 4. Okay, let's try some more here, ladies and gentlemen. So factor each of the following. So 6x plus 24. Hey, what's the number that goes into both those? 1 does, 2 does, 3 does. But what's your biggest number that goes in? You always want the greatest common factor, and it's 6. So 6 goes into both those terms. So what's left over, divide each thing by 6. So kind of just mentally vision this. 6x divided by 6. The 6's are going to cancel out, so you're left with x plus 24 divided by 6 is 4. So again, the greatest common factor goes out front, and your leftovers go in the bracket. And now when you factored, folks, you got a product of two numbers. So 6 is one value, and the binomial x plus 4 is the other value. All right, let's take a look at this one. Ladies and gentlemen, B. Is there a number that goes into 8 and 3? Well, yeah, 1 does. But anything else? No. So we're going to take a look a little closer at these terms and see if there's anything in common. Hopefully you recognize that there's an x. So we're going to focus out a common factor of 1x. So when you divide each term by x, you're left over with 8 because x divided by x cancels out, minus 3. The x's cancel out, but you're still left with the y. Okay? Now taking a look at this one. Wow. C is getting a little harder. This is probably the new stuff. You probably didn't have something this difficult in grade 9. Okay, so looking at a number that goes into both 6 and 2, and you know that's 2. And now you look and notice that, hey, both my terms have m's in them. So you always look for the lowest power. So m squared is going to be your greatest common factor. Your leftovers are going to go in here. So if you need in a margin to do this, visualize it. 6m squared divided by 2m squareds. Okay, what happens to your m squareds? They cancel out. And 6 divided by 2 is 3. Subtract, try the next term. 2m to the 5th divided by 2m squared. Well, the 2's cancel out. I forgot to put the negative sign in there. Okay, so we got the negative sign already. And remember, we got to use our integer laws. When we're dividing, we subtract, so it's going to be m to the power of 3. All right, so that's common factor where you have a monomial out front. Okay, and we've only done this expression when you've got two terms. You don't necessarily need to write this down, but it says if there are more than 2 terms in the polynomial to be factored, we continue as usual. So instead of looking at 2 terms, you have to look at all 3 terms. So let's take a look at this first example here. What's a number that goes into both 6x, 3y, and 9? And hopefully you get that that's a 3. And so we're left over with 2x plus y plus 3. Okay. Taking a look at our second example, ladies and gentlemen, this one's a lot harder. Okay, we got 4 terms to deal with. And a question came up before, and I'll make sure we mention it. When do we put a negative out front for a greatest common factor? The only time you do that, folks, is if every term in your expression has a negative. Then you take the negative out. But say 3 are negative and 1's positive, they all have to be negative. So just keep that in mind. All right, taking a look here, folks, let's do the number first. So what number goes into both 14, 28, 7, and 49? Well, that's 7. Now we're going to look at our x's. Do we have x's occur in each one? Yes, the lowest power is just x to the power 1, so it's just x. Look at the y's, and y's occur in every case, so we have a y. So our greatest common factor is 7xy. Follow me how you do this, folks. We've got a positive divided by a positive, that's a negative. 14 divided by 7 is 2. X squared divided by x is just x, and the y's will cancel out. Next term. Positive divided by a positive is a positive. 28 divided by 7 is 4. X to the power 3 divided by x is x squared. Y squared divided by y is just y. Okay, taking a look at our sign for the next one. A negative divided by a positive is a negative. 7 divided by 7 is 1. They cancel. X divided by x is 1. They cancel. So we're going to have y to the 4th. Okay, and the last one, ladies and gentlemen, 49xy. The 49 divided by 7 is positive 7. And the x's and the y's cancel out. Okay, you will always have the same number of values or terms in your bracket as you did in your original question. So even if you had something that totally canceled out, you'd have to put a +1 down, and I'll show you that example down below. Okay, apologize for the interruption. Sorry for that interruption. All right, sorry for that interruption, guys. Here we go. I'm doing live video and I'm doing it on my lunch hour, actually. So here we go. Taking a look at C, greatest common factor. Hopefully you can try saying that it's 5. Now M occurs in every case, so what's your smallest m? M squared. And N occurs in every case, but the smallest value for exponent is cubed. Okay, so divide each through and you should end up with 3n squared minus 4mn. Okay, and last one, plus 6m cubed, and the n's to the powers of 3 canceled out. Okay, all right, so that's when you have a monomial out front, but we're going to change things up. This is new. Okay, what happens when the common factor is a binomial? Well, you end up with 2 binomial products. Okay, and this is actually, I find, easier than what we did above. So just pay attention and watch. You'll see how easy this is. Looking at example A, it says to factor. Notice there's an A plus C common. So instead of having a greatest common factor that's a monomial, my greatest common factor is a binomial. It needs to be in brackets out front. And then the leftovers are what you would currently still be multiplying by, and it's just your leftovers, 2 minus 3a. Because they're already factored, you just collect them. All right. Let's try the next one. Taking a look at the next one, try not to have this as a trick, but when it says 6w plus y is the same as y plus 6w, it's the same as a plus b equals b plus a. As long as the signs are the same, you're good. So I'm going to go 6w plus y. It doesn't matter if you did the other one, that's fine. Okay, but the leftovers are what are currently multiplied by it, so it's going to be negative 4v plus 7wxy. Okay, notice 2 binomials as a product. All right, why do we factor? So we can simplify equations. I want to also get you to think that we're going to be ending up in what's called factored form. And that's one of the forms of the quadratic, which tells us the zeros or the x-intercepts. So that's another thing we do it. But remember, when we ask to factor, you're going to divide and simplify. But to check your solution, you do the opposite. So the opposite of dividing is multiplying. And what do you do for that? You expand. Okay, so this one says to factor and check. So you're going to factor it first, do the opposite, and make sure you get back to the original question. Here's a note to remember, guys. On your unit test, you're either going to, 5A unit test, you're either going to be factoring or expanding. So you can do the opposite. Thing to make sure you have your correct answer. All right. Even if I don't tell you to, please do it if you've got extra time. All right, let's try this, folks. So first I'm going to do a factor, and then we'll check after. So what's the greatest common factor here? Hopefully you see a 4 and a d. So 4d is your greatest common factor. Okay, and when we common factor out the first term, 12 divided by 4 is 3, d squared divided by d is d. Be careful with this next one. This is where it gets tricky. Negative divided by a positive is a negative. 4 divided by 4 is 1, and d divided by d is 1. So 1 times 1, or 1 divided by 1 is 1. You always have the same amount of values in your bracket as you do in your original question. Okay? We're going to check it. So you write the word check, you write down your answer, and you do the opposite, which is multiply through. So you expand it. Okay? And actually do it, folks. Don't just look to the answer. Actually do it to make sure. So we've got 12d squared minus 4d. Check to make sure it's the right answer. Yes. If not, go back and make sure that you've either maybe missed a sign or divided incorrectly. Double check it. All right, last example here, folks. Taking a look, greatest common factor. Notice here, every term is negative, so negative is part of our greatest common factor. The number that goes in is 3. And the variable that goes in is r. Do we have enough s's for everyone? No. So you can't include s because it doesn't occur in the last term. All right. So watch your signs are going to change here. Negative divided by a negative is positive. 1 divided by 1, or 3 divided by 3 gives you 1 over 1. R squared divided by r is r, and then you got to add the s. Okay. Negative divided by negative is a positive. 15 divided by 3 is 5. The r's cancel, so you've got s left over. And your last term, a negative divided by a negative is a positive. And 30 divided by 3 is 10. Watch your exponents here. R to the 5th divided by r is r to the 4th. Let's quickly check this over. We're almost done, guys. So you write your answer down first. and then you do the opposite operation, which is expand. So we're going to expand this through. So it's going to be negative 3r squared s minus 15rs and minus 30r to the fifth. Does that match our original question? Yes. So we've got that done. So ladies and gentlemen, here's your homework tonight. Complete the worksheet called Common Factoring, folks. There's one that's called Factoring, the other one's called Common Factoring. I think it's on the back side. Make sure you have the one that says Common Factoring, because we haven't got into the other handout that says Factoring. And do numbers 1 to 6, folks. And it says to check 2b, 3b, and 4b. That is not written on your worksheet, so make sure you do that. And as always, folks, if you need some help, come and see me. Have a great day.